Algebra. Have you heard that term before? Today, in math class, we're going to be talking about using algebra in our equations. The official word for it is actually algebraic notation, but it's not nearly as scary as it sounds. Really, when we do algebra, we're putting letters into equations. Before we start doing that, it's really important that we do a little bit of review. Hopefully, before you guys started listening to this video, you watched the PEMDAS video. That's the review song that Vocabulary does. If you haven't watched that video, I'd like you to pause this video and go back and listen to the song. It's important that that order of operations is fresh in your mind. First comes parentheses, then exponents, multiply, divide, add, subtract. Yeah, you know this. So, if you need to, go back and listen to that video now. If you've already listened to it, then you're ready to move ahead. So let's begin our review. In your video today, you will need a piece of paper and a sharpened pencil. If you don't have those supplies, you'll need to pause the video and grab those now. To make sure that you've completed watching this video, I'm going to ask you to take notes as you listen. I'll make sure and be clear to let you know what I'd like you to write down, so don't feel like you need to write down everything on the page every single time. I will be checking this as part of your homework for tomorrow, so make sure that you listen to the entire video and take notes throughout. I would like you to write down number 7 on your notebook paper. Once you've written that down, let's use PEMDAS to solve it. When I'm using PEMDAS, I first start with whatever is in parentheses. I see that 35 divided by 7 is in parentheses. Now, if you're not feeling confident in your division facts, try using one of our factor triangles. Remember, if 35 is at the top, 7 is one of my factors. 7 times what is 35? You should be thinking 7 times 5 is 35. 35 divided by 7 is 5. I'm going to cross that out and add 5 on the top. I don't have any exponents, and it doesn't look like I need to multiply and divide. Oh, there's a division symbol. What's 30 divided by 5? I'm going to make another factor triangle. I'm going to put 30 on the top, 5 on the bottom. Well, I know that 5 times 6 equals 30. 30 divided by 5 is 6. Let's move on to number 8. Write number 8 down on your notebook paper. In parentheses, 72 divided by 9 divided by 4. Now that you have that equation written down, the first thing that we should do should be filling out what's in the parentheses. 72 divided by 9. I'm going to ask myself, 9 times what equals 72? Well, I know that 9 times 8 is 72. I've solved what's in my parentheses. Now I need to do 8 divided by 4. If I have 8 cookies and I split them between 4 friends, how many cookies does each friend get? They each get 2 cookies. Let's look at number 10. Number 10 is using subtraction. First, I'm going to do what's in parentheses, 9 minus 1. 9 minus 1 is 8. I don't have any multiplication or division. Now I'm looking for addition and subtraction. 13 minus 8, I'm going to start with my 8 and count up. 9, 10, 11, 12, 13 is 5. I'd like you to choose either 9, 11, or 12. Pause the video and solve one of those three equations. Now that you've solved one of the three equations, let's see if you got it right. If you did number 9, you should have gotten 20. If you did number 11, you should have gotten 190. And if you did number 12, your answer should have been 80. Now that we've talked a little bit about the order of operations using our acronym PEMDAS, I want to remind you guys about our properties of multiplication. These should be familiar because we've talked about them multiple times throughout the year. Let's quickly go through each of them as a quick refresher. Starting with the identity property, you don't need to write any of this down, you can just listen. This is a reminder that any number multiplied by itself is that number. My examples are 7 times 1 equals 7 and 9 times 1 equals 9. That's true for any number, no matter how big or how small. And it's the same with the zero property. The zero property says that any number that is multiplied by 0 is 0. So 5 times 0 is 0, and 8 times 0 is 0. Just like the identity property, it doesn't matter how big or small my numbers are. If it's multiplied by 1, it's itself. And if it's multiplied by 0, it's always 0. The next property that we need to talk about is the commutative property. The commutative property says that I can flip my factors round and round, and I'm always going to get the same answer. In our problem here, it's telling us 8 times 3 equals 24. If I flip those factors and make it 3 times 8, the answer's still 24. The associative property gets into a little bit more complicated because all of a sudden we have 3 factors that we're dealing with. We have 5, 2, and 8. What this property is saying no matter how I group my factors, if I first do 5 times 2 and then multiply by 8, or if I do 2 times 8 and then multiply by 5, it doesn't matter. I'm still going to get the same product, 80, both times. It doesn't matter which factors associate with who, 5 times 2 first or 2 times 8. As long as I'm multiplying all 3 factors, I'm going to get the exact same answer. Our last property is the distributive property. Let's take a closer look at that one. The distributive property can sometimes be the most difficult property in multiplication, but it doesn't have to be. Let's review what the distributive property is. When I have an equation that looks like this, what I'm saying is that I can distribute my 7 to the 5 and to the 3. So, if I don't have anything there, I can assume that I'm multiplying. And I can do 7 times 5 plus 7 times 3. I distributed the 7 out, just like I pass paper or distribute paper around the classroom. I'm distributing my 7 to my 5 and my 3. This problem also works the opposite way. If I notice that I have a factor that's the same, my 7, I can squeeze it back together. I have my 5 plus my 3 that I can put in parentheses, and I can leave my 7 on the outside. Let's look at another example. If I have an equation like 7 times 2 plus 8, I can distribute that 7 to the 2, 7 times 2, plus 7 times 8. If I have another equation, like 3 times 6 plus 3 times 4, I can take my repeated factor out and put my other factors, 6 plus 4, in my parentheses. I know that's a lot to remember, but this should be a review, and it's something that we'll touch base with in following lessons as well. We've done a lot of review so far this video. We've talked about the order of operations and the properties of multiplication. And you might be wondering, Mrs. Holly, what does this have to do with algebra? When we start to learn algebra, what that really means is that we're putting letters into equations. And sometimes that can look scary. So making sure that our old lessons are fresh on our mind can make our algebra seem a little more easy. Let's start out simple. Here are 6 problems using different letters. Now, don't get afraid. Using letters in math seems a little weird, but it's really not. On your paper, I'd like you to write down number 1. Number 1 says n plus 5n equals. Now, don't let the letter n make you scared. When I'm doing n plus 5n, what I'm really doing is I'm putting a little 1 in front of my n. Now, 1n plus 5n is 6n. That seems like pretty simple addition. The answer is okay to have an n in it. There's nothing that tells you what that n is, and so I can leave it in the answer. If I ever have an n or any other letter that's standing all alone, I can put imaginary 1 in front of it. Let's move on to the next one. Write number 2 on your paper, 17t plus t. Using our trick, knowing that if a t is standing alone, I can put an imaginary 1 in front of it. 17t plus 1t is 18t. There's nothing to be afraid of here. Let's move on to number 3. X plus 245x. Our trick is that this x is really 1. So 1x plus 245x is 246x. Do I need my x here or any of my other letters for that matter? Yes, I do. Because later on, I'm going to be telling you what x means. Maybe x equals 12. And we'll talk about that. But it's important to keep your letters there. Let's move on to 4. Now we're using subtraction, but our rules are still the same. 9e minus 1e is 8e. Write down number 5. 8c plus c plus c. As you were writing down number 5, did you add a 1 in front of your c's? 8c plus 1c plus 1c is 10c. Pause the video and see if you can solve number 6. Now that you've solved number 6, let's go over it. We're going to use PEMDAS as a reminder. We're going to use what's in our parentheses first. 5z minus 1z is 4z. 4z minus 1z is 3z. If you got 3z, you're correct. That was pretty easy, wasn't it? Using what we know about the properties and what we've practiced a little using letters, we are going to find the value of the box or the letter A. Let's look at number 13. 49 plus 17 equals what plus 17? Hopefully you're thinking, hey, 49, 49, 17, and 17. The box is 17. This is an example of the commutative property. Remember, the commutative property is when you flip your factors around and it doesn't matter. In this case, since we're adding, they're called add-ins, not factors. But because multiplication and addition are similar, the same rule applies. Let's look at number 14. You don't need to write this one down. Just watch me as I solve it. Don't allow the A to make you scared or nervous. You're going to be solving for what that is. Looking at all of the factors, I can notice that I have a 2, a 2, a 3, a 3. It looks like I'm missing my 4. A must equal 4. Does anyone know what this property is? Hopefully you yelled out the associative property. It doesn't matter which factors I solve first. I still get the same product. See if you can solve number 15. Pause the video until you have your answer. You should have gotten 8. 8 times 6 is the same as 6 times 8. Number 16 is challenging. It should remind you a little bit of the distributive property. If I have 6 times 40 and 6 times A, let's look and see what we're missing. 6 times 40, 6 times 5. A equals 5. 17 is the distributive property as well. Can you figure out what the box represents? See if you can figure it out. Pause the video until you've got it. Hopefully you realized that 7 is what the box represents. The 7 was distributed to the 5, 7 times 5, and to the 9, 7 times 9. If you're still listening to this video, you're doing an awesome job. I'd like you to put 3 stars at the bottom left-hand side of your page. I'll be looking for those stars tomorrow. We're almost done, and this is our last slide. Earlier in the video, I told you that sometimes letters would represent a number. In questions number 34, 35, and 36, each letter represents a different number. Looking at number 34, A represents 4. When I see that A represents 4, I'm just going to cross A out and put in a 4. Now I can actually solve. First, I'm looking at my parentheses. 4 plus 6, I know is 10. Now I'm solving 19 minus 10, which is 9. I'd like you to solve 35 and 36 on your own. Once you've done that, you can play the video and I'll show you the answers. Now that you've solved 35 and 36, let's solve them together to see if you got them right. You've seen that I've replaced the A for 35 with a 10. 80 divided by 10, we can use our division trick. Taking out my zeros, 8 divided by 1 is 8. Don't need to add my zeros back in. 8 minus 5 is 3. My answer is 3. For number 36, I'm going to cross out the B and put in the 3. Using my order of operations, I know I need to do the first parentheses first. 8 divided by 4, you should have said is 2. 7 minus 3, you should have said is 4. Finally, I'm going to multiply 2 times 4, which is 8. You guys did a wonderful job listening to our video today. I hope that algebra doesn't seem nearly as scary as it did when you started the video. Have a wonderful day. Enjoy the snow. I'll see you tomorrow. Now that you've completed the video, you do not need to complete any extra homework packet pages. The only thing you'll need for tomorrow is your notes from today's video and your homework from yesterday, which was page 201, 202, and 203. Thanks for listening. Can't wait to see you.